The last unit before we hit the 3D, which we're not going to review here, is circles. So let's go ahead and review all of our circle operations. First thing, we got some tangents. If you know that you have two tangents in this problem, and it doesn't really say, but these are tangents, then you can set them equal. If you know their tangent, you can set them equal because they are equidistant from the circle. So let's see, 2x plus 13 equals 4x plus 8. I get 2x on one side, add 8, you get 21, divide both sides by 2, and you got x equals 10.5 for the first one. Second one, you have a chord being bisected, and I know it's perpendicular, which means it's also a perpendicular bisector. So this is a diameter, and you have a chord being bisected, so I can set these two segments equal to each other. 9x minus 3 equals 7x plus 5, and then it's just a matter of solving again. If 2x is 8, then x equals 4. For this one, you have chords that are equidistant from the center. That's what these are indicating, which means they are congruent. So I can say 3x minus 11 equals x plus 9, and then I can get all my x's on one side. 2x is 20, so x equals 10. You just have to remember your chords and tangent rules for those. For the second section here, it says find the measurement of MN. Arc MN is right here, so since this is a central angle, I'm just going to do 85 plus 45, and the measurement of arc MN is 130 degrees. Here, if I'm trying to find MN, another minor arc, I'm going to have to use the fact that these two arcs, 160 and 35, those plus this arc are going to add up to 360. So I'm going to say MN, arc MN plus 160 plus 35. If you add all those together, you get 360, and if you subtract, you're going to get arc MN is 165. I should say that's the measurement arc MN, 165. For 21, I'm going to go ahead and find this arc, and since they're telling me that these arcs are congruent, what I'm going to do is call this central angle x and say 140 plus 100 plus these arcs are also the same as the central angle, so plus 2x equals 360 because all the arcs of a circle add up to 360. But if you subtract the 240, you get 2x is 120, and then if 2x is 120, then that means that x is 60. So the measurement of arc MN would be 60 degrees. So is that central angle, so is that central angle, and so is arc PN if you need them. Here, if I'm trying to find the measurement of angle C, that's this one, I need to probably find the angle of these guys because I have an isosceles triangle since those are both radii. So what I'm going to do is use the fact that this is 28 to find this arc. Remember, since this is an inscribed angle, it's half of the arc. So if that's 28, this is 56 degrees, which means this angle is 56 degrees. Now you have an isosceles triangle where you have these are congruent angles. I'm going to call those x. So I could say x plus 56. Those have to add up to 180, which means 2x is going to add up to 124 because 180 minus 56 is 124, and then if you divide both sides by 2, you get 62 degrees. So x is 62 degrees, which is angle C. If I want to find arc C, I need to know that since these are congruent chords, these arcs are congruent, BC and AC are congruent, and you also need to know that since this is an inscribed angle, it's half of this arc. So if this is 48, this is 96. So what I'm going to do is call these arcs x, and I'm going to write an equation that says x plus 96 adds up to 360. So 2x is going to be 360 minus 96, which if you do 360 minus 6, you get your 264, which means if you divide by 2, you get x is 132. So x is 132 degrees in this one. Arc BC is right here, so let's see, what do I know? I know that these are going to be supplementary because they're a diameter. Since it goes through the center, I know it's a diameter. So if that's 138, I could do 180 minus 138 and say this has to be 42. And if that central angle is 42, then this arc has to be 42 degrees as well. So arc BC is 42. For the bottom here, you have to know that the opposite angles of an inscribed quadrilateral are supplementary, so I can say 2x plus 64. Those have to add up to 180, and I'm just going to set the other one up while I'm at it. 4y plus 64 is also 180. So then to solve these, I would subtract 64, so I get 2x is 116, and if you divide, you get x is 58. Pretty much the same deal here. 180 minus 64 is 116 again, and then I can do y equals 29. Let's see, this one I'm going to have to do a little bit more work. So what I'm going to do is first solve for x. And notice how this inscribed angle opens up to form those two. Those angles, those arcs add up to 144 degrees. So if the inscribed angle is half the arc, I could do half of 144 and say that 12x is half of 144, which is 72, which means x is 6. For the other one, I'm going to have to do a little bit more work and first find this. So FG has to be 171, and I know that because I know all the other arcs, and I know that they have to add up to 360. So if you do 360 minus 45 minus 96 minus 48, you get 171. Then I'm going to add up 48 and 171 because this angle opens up to form that arc. So those form 219 degrees. The angle is half the arc, so I'm going to do 3y is half of 219, which is 109.5. That's a lot of work to get it set up, but then to solve, you just divide both sides by 3 and get 36.5 for y. For the last one here, ST, I'm going to try and find this arc. What I'd like to know is, what is this arc? And since this angle is inscribed, I can say, well, double that and you get 122. If that's 122, I can say these have to add up to 180 because this is a semicircle since this is a diameter. So if I do 180 minus 122, I get the measurement of arc ST is going to be 58 degrees. And we're now done with the front page.